So, in terms of picking a major, originally I wanted to do biomedical engineering, and that's because during my junior year in high school, I watched this TED Talk about prosthetic limbs, and I was just really interested. And when I came into Tufts, I originally planned on doing BME, but I learned that Tufts actually does more tissue engineering and not more the mechanical aspect of it, which I was interested in. So I decided to do mechanical engineering instead, and I figured that like if I go to graduate school, then I could focus on the BME aspect. All right, so my favorite class actually is Physics 11, and it's weird because while I was taking it, I hated it, but it was after I completed it I actually liked it. And the reason is the instructor is different from the other professors that I've had at Tufts, and he really stressed on actually learning the material, or not learning the material. It's like you developing an intuition to like solve problems, right? Rather than traditional engineering classes is you have a problem, these are the formulas, and then you kind of like have to develop a sense of like how can I use these formulas to solve this problem, and kind of like in that sense develop an intuition. But his method was different. It was more conceptual, where you would look at a problem and then without even like thinking about equations, think to yourself, okay, this is how I think this is going to happen. And just developing an intuition like that to solve a problem, I think is just, I don't know. I felt more comfortable with the material, and even though like I haven't taken like his class since like freshman year or whatever, if I were to like solve problems right now just because of that intuition, I wouldn't struggle as much as if I were to like, for example, take like a thermodynamics class again. Like I feel like I'd be lost for a while. Favorite project would have to be in my machine design class. We had this cantilever beam, and there was a force that would be applied at like the tip of it. And the whole point of the project was to figure out, well, okay, I'm going to apply like a 200-pound force, and I want you to like design a beam that's going to deflect exactly half an inch. And it was weird because we had two methods to use. We could use this method called Castigliano's theorem or SolidWorks. And it was like software versus like actual formulas that someone wrote like way back. And the reason why I like this project is because you would think that nowadays with all this technology, like SolidWorks would be more accurate, but it turned out that like with our calculations, the theoretical calculations that we did with the Castigliano were exactly correct with what actually happened when we tested it. And that really boggles my mind, like to this day, that like using these formulas, like I was actually able to predict how it's going to work, and like the software wasn't able to do it as accurately. I mean, it was close, but it wasn't perfect. But yeah, that project just like was my favorite one. So summer after freshman year, I took a chem class just to sort of like get ahead, and I didn't like chemistry, so I figured if I took it in the summer, I could just focus on that and not worry about anything else. So I thought that was like a great idea. And then the rest of that was the first summer session. The rest of that summer I was just working on campus for helping this bridge program that like helps high school students transition to college. That was fun. Sophomore year, after that, like I did, it was like an internship slash, I'm not sure, there wasn't like an official title, but I was working at the Center for Engineering Education and Outreach. And I was doing some software things like web programming and a little bit of like 3D printing. And that project I thought was really useful because what I got out of that was learning how to work on my own. Because my advisor would just tell me, okay, well, I want you to like do this, and that. But then I'll be like on my own trying to like figure out how to do this. And like a lot of the time it'll be things that like he wasn't sure whether or not it could be done. And I just had to like, go on the internet, find like whatever like anyone else has done before, figure out, okay, can I grab this, can I grab that, can I put it together, and like, so it was challenging because a lot of time I felt lost, but it was a good learning experience because at the end I felt that just by having to like look at a bunch of different things, I learned a lot. And this past summer, I was doing research with Professor White at the Tufts Micro and Nano Fabrication Facility. I was building ultrasound transducers specifically for measuring wind velocity in a low pressure environment. That was pretty cool because I got to like wear a bunny suit a lot of the time and just go in the lab and like build sensors. That also was like really frustrating because building is like a wafer, like sensors from scratch, starting with like a glass wafer and having like a layer of metal and then another layer of metal. It's a really not delicate, but like really specific process. So if you mess up anywhere along the way, there's like a possibility that you have to start over. So that's like frustrating because like I would keep on failing over and over and over and over. And my advisor at times was just like, that's the point of research. You got to just keep trying. But I've definitely gotten better at it. I'm still doing research on that this fall and probably through the spring. And that, I think, research experience taught me, okay, things are not always going to work out, but it's fine. That's the whole point of research. You just got to keep trying different things and figure out, well, okay, why isn't this working? What can I get out of that? And how can I like change it up, make it better? But yeah. So in terms of picking a major, what I recommend is try to think about not your current like undergraduate career, but think more so what you would see yourself doing after graduation, as in professional field like work. Do you see yourself, doing more things like in the lab or like in a chemistry type environment, or do you see yourself being more like out in the field, like maybe something more civil, or like pretty much think about like where would you kind of like see yourself at. From there, like if that doesn't help, then think about what subjects you're interested in. If you're more interested in physics, then I recommend like as in mechanical aspect of it, consider mechanical engineering. If you want to do electrical stuff, electrical engineering. If you're more interested in chemistry, then start out with chemical engineering. But the thing is don't stress too, like your freshman year, you shouldn't like stress too much about which way you go, because I think that like it's possible you can make the switch at any point in time during your freshman year. Sophomore year might be tough. Along with that, I think that it'll be useful to also look at like different research that like professors are doing in different departments, because I think that like at some point during your undergraduate career you might be interested in doing research, and look at what different people are doing in different fields, and then just think to yourself, oh, like would I want to like try that out? And like don't worry about understanding everything that's going on, just like get a sense of what they're doing and see if that's something that like appeals to you. And I think just from like picking up like these different things that people are doing, you might get a sense of what you would want to do.